Let's continue with solving quadratics using the quadratic formula. So the first thing we need to do is get this into standard form. Standard form means that this equation equals 0, and this one clearly does not. So let's move everything over here to make it equal 0. I typically want to keep this x squared term positive. You especially do when you're factoring. It's not quite as important whenever you're using the quadratic formula, but I like to just do it every time. So my formula or my equation is now going to be x squared minus 10x plus 61 equals 0. I subtracted the 10x over and added the 61 over. Okay, so now this is in standard form where I have everything on one side of the equation and it equals 0. So now I can list my A is 1, my B is -10, and my C is 61. So now let's use our formula, and I'm going to rewrite it so we can see it. We get -b plus or minus the square root of b squared minus 4ac all over 2a. So let's substitute in. My -b is -10, so this is actually 10. Plus or minus b squared, so put that -10 in parentheses, minus 4 times 1 times my c, which is 61. And that is all over 2 times 1. So let's simplify. I've got 10 plus or minus the square root of something. I don't know what that number is. Definitely not going to be as big as my first radical was. And then all over 2. Okay, so let's see what number we get here. Oops. Okay, we get -144. Okay, when I get a negative under that radical, if you notice here, if I do the square root of that number, I'm going to get an error because it's a non-real answer. When you get a negative under that radical, this is when we get imaginary answers. We get complex answers. We get i's in our answers. So if I come over here to the square root of -144, this is the same thing as the square root of 144 times the square root of -1. The square root of positive 144 is 12. And the square root of a -1 of any negative, that's your I, your imaginary. So this becomes 10 plus or minus 12i all over 2. You again want to look, is the number before the plus or minus, the one in front of the radical, which that's what an I is. An I represents the negative square root. And the number below, if it's all divisible by the same thing, it is also divisible by 2. So we're dividing everything by 2. 10 divided by 2 is 5. I did it again. 12 divided by 2 is 6, so 6i. And then 2 divided by 2 is 1. You can put it all over 1, but that's not necessary. I did show you in the last video that you can check your answers on your calculator. You can't really do that with these exactly, but you can a little bit. If I put this in my calculator, Okay, and I graph this. And let's change our window. Let's go negative 100 to 100 with a scale of 20. Negative 100 to 100 with a scale of 20. Okay, so here's my quadratic. When we are finding this, all you are doing is solving for when y is 0, which is your x-intercept. Your calculator calls it your zeros. If you graph this and it does not touch that x-axis, that's when you get these imaginary numbers. And so because when I graph it, it's above that x-axis, then it's imaginary. The same thing would happen if it was down here. Let's see if I... Okay, same thing here. If it's down here below, right, and you see that turn and it's never touching, you're going to get another imaginary answer for that quadratic as well. Okay, so you can't really check that 5 plus or minus 6i is the right answer, but when you graph, you can check, okay, well, that was supposed to be imaginary. Okay, and then our last example on the quadratic formula. This is not in standard form, so let's move that 6x over to get it into standard form. We get 12x squared minus 6x plus 10 equals 0. If you do notice with this one, we do have a GCF. If you want to take a GCF out of 2, you can, and it makes your number smaller. But if you are not solving by factoring, it's not really necessary. So I'm just going to leave it this way, but if you wanted to make this 6x squared minus 3x plus 5, you get the exact same answer. So now that this is in standard form, let's list my A, B, and C. So A is 12, B is negative 6, and C is 10. I'm going to rewrite my formula so that I have it in front of me. The more times you write it, the better you are at memorizing it. A little helpful hint there. So negative B, again, negative 6 is positive 6. Okay, that negative B means I'm changing the sign. B squared, because my B is negative, you have to put those parentheses around it. Minus 4 times A times C. And this is all over 2A. Okay. So let's simplify. And I'm going to get x equals 6 plus or minus the square root of something all over 24. So let's again see what's under that radical. So I get parentheses negative 6 squared. And if you're not trying to enter this in, I highly suggest you do. Because if you can do this, but then you can't put it in and get a number here, then that doesn't really help you. Make sure you know how to put these in the calculators, guys. So I get negative 444. Okay, we have to simplify this. So the square root of negative 444 is the same thing as the square root of positive 444 times the square root of negative 1. Well, I know negative 1 is where my I comes from. So now let's break this down. 444, I bet you it's divisible by 4. Well, there we go. We get 111. 4 can be broken down to 2 and 2, so there's a pair. I know I can break this down by 3, and we get 3 and 37, but 3 is prime and 37 is prime. So we can't break that down anymore. So we get 6 plus or minus, the 2 comes out, the I comes out, and then square root of 111. We'll multiply 3 and 37 back since they don't have pairs. And then this is all over 24. I am looking. Does the number out front of your plus or minus? Does the number in front of your radical? And does the number below, are they all divisible by the same thing? And yes, they are. We can divide them all by 2 again. 6 divided by 2 is 3. So you get 3 plus or minus. 2 divided by 2 is 1. So you can either do 1i or I will just do I square root 11. That does not get changed. That's not divisible by 2, and it doesn't matter if it was, we would not divide it. Just like up here, well, on the last lesson, we didn't touch what was under that radical. And then 24 divided by 2 is 12. So these are my 2 answers. And again, if you were to graph this, you would see that it would never cross that x-axis.